So, good evening everyone. I am Giancarlo Nervida and today we will compute the water. Water source, the farmer wants an efficient and low-cost irrigation system. And so, good evening. So, firstly, we will they give the uh, given area, which is the 1 hectare or 10,000 square meter. Also, the water requirement, which is the 60 millimeter per day or 0.06 liters per day. I mean, 60 liters per day. So, step 1, to convert the volume, we will need this volume equals area times depth. Which is volume equals 10,000 times 0.06, which is 600 cubic meter per day. So, to convert the discharge, so step 2, which is Q equals volume divided by time. So, which is the given volume is day, which is 1 day is equals to 86,400 seconds. And next is discharge equals 600 divided by 86,400 is equals to 0.00694 cubic meter per second. So, the final answer is 1 the discharge is equals to 0.00694 cubic meter per second, or discharge is 6.94 liters per second, which is this. Okay, so moving on to the sa second problem. So this time we'll choose rectangular canal, which that is considered the simple and common. So we have this given, which is the velocity is equals to 0.4 meters per second, and the discharge is Q equals 0.00694 cubic per second. So step 1, area is equals to discharge divided by velocity, which is 0.00694 divided by 0.4 is equals to 0.01735 meters squared. So to solve its dimensions, and step 2, assume that the width is equals to 0.2 meters, and its depth is equals to A divided by B, is equals to 0, this is width W, 0.0173735 divided by 0.2 is equals to 0.08655. So the final design is which is the shape is rectangular. The width is 0.20 meter, and the depth is equals to 0.09 meter. So in problem 3, we will have to determine the horsepower recommended. So firstly, we will write the given formula. So Q is equals to 0.00694 cubic meter per second. However, this time we will use these we will use liters. So let's put R Q, I mean 6.94 liters per second. So the H is equals to 3 meters, and the efficiency, which has this symbol, is 0.7. And then so let's firstly introduce the formula, which is one of the fundamental or important in this. So the formula is HP is equals to Q times H divided by 75 times N. So this time HP equals to 6.94 times 3 over 75 times 0.7. So, HP is equals to 20.82 divided by 52.5, which will lead to 0.3966 or 0.40. So, this uh, we will this time we had this 0.40 horsepower pump. However, this is quite small, but this, so we will use the 0.5 horsepower pump since it is the nearest standard size and not costly and not and practical minimum. So what is a ram pump? A hydraulic ram pump is a device that uses energy of flowing water to pump water to a higher elevation or higher places without electricity. So how does it work? A water flows from the source, and then next is the pressure builds up, and then a valve suddenly closes, and then the pressure pushes water upward to the farm. So what is the advantage of this? So it doesn't need electricity, and it is also low operating cost, environment friendly and durable. And its limitation is it needs continuous flowing of water, requires elevation difference, and not suitable for very large discharge. It is applicable, yes, but it is as a condition. So since water source is only 3 meters lower, ramp pump might work, but the efficiency is the issue. So if much lower, the it must higher need of elevation, the less efficient the hydraulic pump would work. So what is the real life application? Um, Considering that crops needs water to grow, so those processes are needed to cultivate cultivate crops. So also the irrigation canals, the rectangular canal design is which is which is called mas simple, and it is also efficient and less cost, not so complex and or complicated, and it is very practical. And then the next is the use of water pumps. Since it lifts water river to the farm, it ensures continuous irrigation, and commonly it is used in rural areas. And then so in the ramp pump earlier is doesn't need electricity, so it is actually quite, I mean, it is really important. And then so it is also important to farmers to prevent crops from drying during drought seasons or hot days. It also increase crop yield and reduces labor and use water efficiently.